Let's start at the very beginning, a very good place to start. When you read, you begin with A, B, C. In bonding, you begin with the octet rule. Octet rule, octet rule. Each valency electrons just happen to be stable and cool. Octet rule. 1, 2, 3, 4, 5, 6, 7, 8.
The octet rule is a general rule that allows us to predict how atoms will form chemical bonds to make molecules. For example, why do the two elements hydrogen and oxygen bond to make the molecule water? Why do sodium and chlorine make table salt NaCl? Why don't the noble gases react with anything? Why are they already stable? The octet rule will explain it. Oct means 8. A stop sign is an octagon, a shape with 8 sides. An octopus has 8 legs. And an octave has 8 notes. 1, 2, 3, 4, 5, 6, 7, 8.
When elements have 8 electrons in their outer shell, they have an octet.
The electrons in the outer shell, or the highest energy level, are called valence electrons. Potassium, with just one valence electron, does not have an octet. Last quarter, we drew atoms and we saw there's a pattern to the valence electrons, and there's only one group that has an octet. You know it, it's the noble gases. Here's neon with 8 valence electrons. Studies have shown that 8 valence electrons is stable, and atoms always want to be stable. The octet rule was developed to explain many observations of how atoms behave in real life. The octet rule: atoms will react or bond by sharing or transferring, losing and gaining electrons to achieve a full valence electron shell. For most atoms, full equals 8, a stable octet. Take Na, sodium. It's in group 1, so it has 1 valence electron. It does not have a stable octet. It either needs to gain 7 electrons to fill that highest energy level, or it's easier for it to just lose 1, and now the energy level underneath is full. It actually has the same electron configuration as neon, the nearest noble gas. Okay, take a look at Cl, chlorine. In group 17, it has 7 valence electrons. That's not a stable octet. It needs 1 more to get to the stable electron configuration that's just like the noble gas argon. In fact, many people think of the octet rule as atoms trying to become like the closest noble gas. But remember, that brings an exception: helium. It only needs 2 to have a full valence electron shell, and so it and the other small atoms are exceptions to the octet rule. For example, hydrogen and lithium both are trying to achieve the electron configuration of helium. Here's lithium. If it could just lose that 1 electron, it'll be just like helium. You might think of it as a duet instead of an octet. Well, students, this is just the start of the story, because atoms can't become stable by sharing or transferring electrons unless they have another atom to do that with. So we'll be learning more about this in the weeks to come. Let's review. Atoms react to achieve a stable octet, 8 valence electrons. They do this by sharing or transferring, losing and gaining electrons. There are some exceptions. For example, the smallest atoms only need 2 valence electrons to have a full and stable valence shell. And that, chemists, is the octet rule. You know what to do. Take a screenshot.